wireless installation. How does that work? Did you install the crossover using Bluetooth? How does it work wirelessly without any wires?
The point is, when you assemble crossovers, you usually use some pieces of wire or something like that. Here, the crossovers are assembled in such a way that there are no wires, minimal connections, and everything is done only with the components that are there.
So the components are connected to each other?
Between each other, yes, that's why.
Using their own contacts, no wires or extra boards needed.
Yes.
What does this give us as a result?
Well, at the very least, it gives us a minimum number of connection contacts, right? Because as soon as we have the part, like the inductor, it goes straight to the driver and there are no other connections, right? Next, here we use an inductor with a transformer steel core because we need it to have very low resistance, right? That's it. So the module components, yes, there are different types, but our capacitors were from Supreme, meaning it wasn't the cheap version. Yes, gold, so there are all kinds of options, but you can experiment there. It's up to whoever wants. There you go. If we had used a high-end inductor, it would have been 350 euros for just one inductor. And the components that are in this little box are packed in mineral wool. Yes, well, mineral wool, the kind that doesn't produce dust, so none of the components touch each other or the panel itself. Yes, so they are kind of suspended in this wool, right? So they are packed tightly, there are no resonances, and the lid is sealed. Yes, so there's really nothing else you need to do. Everything is fine there. There's an adjustment option you can use. We just hadn't talked about it before. About this correction, you just didn't have time for it. Yes, well, I'll tell you now that there's a correction there that can raise the highs and then adjust the lower treble a bit. But in the end, we'll probably stick to not giving this here. We'll just keep it simple. It takes time. Well, you have to listen to a lot, not just with us, but also with other people. Thank God 2 panels have already been sent out. I already know the result, right? It's the same with the big panels that can be installed in the S90. Yeah, so for now, we're still searching.
The optimal option for the filters.
Next.
You mentioned crossover adjustment, meaning there's no dial on the crossover that you can turn to make adjustments. There are just a few contact options there where you can swap the wires to get a different frequency response result.
You can solder the whole component for them. Yeah, raise the highs there.
At 3 minutes 25 seconds, the technical specifications are stated as 40 to 25,000 Hz with a deviation of plus or minus 2 decibels. On the graph shown, which you can see on the screen now, starting from a peak at 200 Hz at minus 6 decibels, there's a drop to minus 24 decibels around 40 Hz. At 8 kHz, there's a dip of minus 8 decibels relative to 1 kHz. What kind of graph is this with a 10 decibel step, huh?
Guys, let me explain. There's this concept called a blank slate, right? This is the raw baseline graph, and this is what you'll be working with. See, there's no information about low frequency here at all. That's why the graph looks like this, yeah, because it was recorded in a large room. Next, there's no correction function here. Nothing has been entered. Yes, so now we can calmly figure things out. These are the stated parameters that we mentioned, and these are actually achievable parameters that can be reached. Now we'll figure out how we measured all this in different rooms, and now we'll get the result. So I'll be telling you, but the chart will be static. There won't be a moving cursor, but in any case, I'll just explain. Now in front of you are charts. 3 charts with correction enabled. Yes, so the pink curve is the on-axis response. On the axis we have quite a significant rise at high frequencies. It can be removed, no problem, but it's an extra detail that will affect the sound, yes. Since this rise starts after 14, here on the axis, and now let's look further. So the red one is 15 degrees, and the green one is 30 degrees. But basically at 20 degrees you get a flat frequency response. Yes, you just don't need to point it directly at yourself, and that's it, don't worry about it. Next, so this was recorded again in a large room with no wall reinforcement, basically an empty room, yes. Now we pay attention, now let's turn it on. So the graph is dark, it's almost black. So we move the speaker closer to the back wall. Here, now we immediately have a room effect, but that's okay. You can see what appeared at 60 Hertz. Basically, we achieved a 6 decibel boost from 140 Hertz. It starts to rise smoothly, about 3 decibels there. Then further, we've already got 6 decibels. Now let's move on to your chart. Yeah, but this chart touches on the next question, about 60 Hertz, right?
Yeah, it's great there.
Great. Well, I just wanted to remind you guys that the resonant frequency of a driver is not the main indicator of its low frequency capability. For that, we also have the Q factor, we also have the equivalent volume, X max, well, and some other things too. So just a reminder, a driver with a resonant frequency of 30 Hertz and a Q factor of 0.2 will barely work up to 50 in the classic setup. And a driver with a resonant frequency of 60 Hertz and a Q factor of 0.6 will easily handle 40. You also have waveguides to help. Do you recall how much lower they can be tuned than the speaker's resonant frequency? So that's why now, if we, let's say, we gave you, you are also given the driver's specifications. With these driver specifications, you can enter them into any program. For example, Bassbox, input the data, press a button, and it will calculate for you that with a maximum volume of 27 liters, this driver with a resonant frequency of 60 Hertz works without any problems with tuning down to 40 Hertz. That's what you'll get in this case. If we're talking about low frequency capability, it's better not to just look at the graph, but to enter it into a program, and there you'll clearly see the acoustic power and everything else, up to what point you can use this driver. So at 50 watts, this speaker will easily produce 103 decibels at 40 Hertz. After that, it will just exceed X max, and that's it. Yes, that's why it's very important where this speaker is located and what kind of room you have. After all, this speaker, this panel, is designed for smaller rooms, yes. Now, for cinema, that's a completely different matter. You can use it in larger rooms because it has good power handling. So let's take Arkady's chart, and what do we see? So look, let's pay attention to the first chart. So Arkady went ahead and measured his room and was shocked by what he found. A whole bunch of questions came up. All right, let's not talk about him. So what did we get with the frequency response? Let's look at the green one first. The blue one doesn't interest us for now. So the green one, according to all the room's issues, that's what we got, yeah? If you now know that we have room correction, then basically, if we apply room correction now, our graph will already fit within 5 decibels, right? That is, plus or minus 2 decibels is practically guaranteed, right? Why?
With room correction, it was about plus or minus 5 decibels for me, but that was automatic room correction in the VM Home app on the VM Amp Ultra amplifier.
Yes, that's the room correction the microphone measures and that we hear, yes. So, I want to draw your attention to the fact that we have 30, if you look at it this way, minus. Well, let's take minus 5 decibels because we'll take 90 decibels as the baseline, right? And so we get 30 minus 5 decibels. Where does the 30 come from? The speaker is working, it's resonating at 38 Hertz, right? There, it's clear that's the room, right? And that's why, let's say, it's very good that it's in the negative at the moment, right? And now, look, so what I was telling you about the mid-range, that's 3 to 4 kilohertz, right? All of this can be raised, including the highs, right? So Arkady couldn't resist. He pressed the button, and the program took 30 as the base frequency and set it in his frequency response, right?
And it sounded better.
It sounded better, but...
And more clearly?
Yes.
And more distinctly.
Yes, but I can say right away.
And the modulation has improved.
I can say right away that if we start listening more closely to the low end, it will have a delay because it was based not on the driver's behavior, but on the room itself.
The room's dynamics?
And you can't do that. That's why there's a manual control. Yeah, you can easily look. So right now we have 30 hertz boosted on the blue graph. Yeah, that means all that rumbling low end in the room will dominate and it won't be any good. There won't be any speed.
I had someone come to listen to these speakers and he was listening and asked, Arkady, where do you have the subwoofer hidden?
Well, there you go.
I said, there's no subwoofer. I just moved the speakers closer to the wall and that was all it took.
So it turns out he was right about the subwoofer because that's not the proper bass, right? What would be the right way to do it? Give it a 40 hertz point to start from. If you could do it manually, you should be able to set where to start and where to end, right?
Yes, you can.
That's it. So it was possible.
I set it from 20 to 20, well, like an audio file.
You should have started from 40 hertz, then everything would have worked out, right? But actually, you didn't have to do anything at all. You could have just used 2 parametric EQ bands, right? Take a frequency of 300 hertz with a low Q factor, let's say about 1.5, set it to -4 decibels, right? And if needed, if you suddenly need to boost the 180 hertz range, that's responsible for the fullness, right? But all of this had to be judged by ear. But don't touch 60 or 70 at all, right? You'll keep your dynamic range, you'll keep all of that, because the speaker can reproduce it. It's hard for it to reproduce those 30 hertz that it boosted, right? And it's basically pointless. Well, there you go. So in the end, all the questions we had have been resolved, right? Now, so guys, don't worry, we're not deceiving you. That's it. We just needed to approach this the right way. I'm not at the age yet where I need to start making things up. Now, I'd like to show you on the chart right now. Look, I want to show you this speaker, this specific one, okay? When the microphone is deliberately placed right next to the speaker cone, here we have the purple graph, that's the speaker cone, so it's near the speaker cone, yes? You can also look at the phase characteristic, those graphs we've been showing you. Sorry, I forgot to mention. The top graph is the phase response, and the bottom one is the magnitude. Yes, but you can go back and see a flat phase response. Also a flat impulse response. You can find this online, you can see it there. We won't overload you with graphs here. So the near field, so we have the purple graph, that's the cone, the driver, the tuning of the bass reflex at 35 hertz, and the red one is the port itself, up close. I cleaned it up here. As you can see, it's just a sloped curve because that's very important. After all, the bass reflex port is 70 millimeters, right? And if you don't handle it properly, especially since it's to the side, yeah, it can...
Up or down.
You can put it anywhere, yeah, but basically...
Right now it's on top.
Right now it's on top, yeah, but basically you can also lay it down. Yeah, but you can't put it upside down because the tweeter should be at the bottom. Yeah, because, as I already mentioned, this is the passive driver. So, for those who are interested, it's 70 millimeters. That's the bass reflex port. And you can roughly estimate the pressure. It's like a program. That's what Bassbox shows, and that's the pressure you'll get. So, don't underestimate a 60 hertz driver with a Q factor of 0.6. It can, yes, it can produce a lot of pressure, but it can easily handle that frequency.
All right, question number 3. Arkady, could you tell us what order crossover is used? If possible, a photo of it. We won't show a photo, that's a secret. What is the crossover frequency of the filter? In front of which driver should your ear be to make this speaker system phase linear? The clearest bass and response in speakers without a bass reflex. Can this speaker system be used in an open baffle or in a sealed enclosure? And what are the manufacturer's recommendations? Is it possible to listen to and purchase this speaker system in Russia? Unfortunately, it is not available in Russia. Come to us, buy it, and take it with you. And for the rest of the questions that are combined into this one, Roland will answer.
Remember I told you about the filters before, right? Here we have more than 24 decibels per octave on the high side. So, and on the low side we have 18 decibels per octave. But that doesn't mean those are the filters I mentioned, right? This is just the result. Because in the end, we're making sound here, not just doing pure math, not just adding things up. So the filters are mine, all my own developments. I've been working with these filters for quite a long time. And these are compensation type filters. That's my own term. You won't find it anywhere else. So, you can use the crossover frequency. So here's what you get. 3.5 kilohertz, a little more crossover frequency. So we're asking a lot of the mid-range driver because it can handle it. It's a sandwich type and very good, not too deep. That is, when the cone is shallow, its dispersion characteristic is very good, yes, and for us that's the main thing. There, next. So the phase response stays within 35 degrees. That is a flat phase, a flat impulse. No, from the mid-range and up.
Aha, got it.
35 degrees, right. That means if your mid-range driver is, well, a little below ear level, right? So you'll be sitting with it below your ear, and if you stand up, you won't lose anything at all, right? The crossover won't break up. Then the crossover will start behaving like a conventional design, right? That means you'll get phase distortion. Well, because the two ways aren't coaxial, right? These drivers have a Q factor of 0.6. That means it can be used in an open baffle design. But since it's an open enclosure, you need to know that, and then you need to apply corrective filtering, right? Because you definitely need to let it go, since the mid-range from the backside will be amplified. Yes, and our sensitivity will increase up to a certain point. Well, up to about 400, 600 hertz. 500 for sure. All of this will increase, right? Right? It's natural that in an open design, it will be hard to push it lower. There's no point, like in a three-way setup, but that's possible, right? If you want to make a three-way setup, I really recommend that you design the low frequency section properly. And this speaker, if it's going to be open, yes, they should still be aligned, and the low frequency drivers should be placed lower, closer to the floor, right? And this driver should still have a slightly different distance, because otherwise it won't work for you. Because if you try to align them in a very wide connection, yes, then you will definitely need to take delays into account. So you will need to do that. If you don't put any filter on it, then you will need to shift it by about 60 centimeters, well, depending on the crossover frequency. But yes, this option is possible, no problem. So, and as for tight bass, listen, from my experience, I'll tell you this. It's all about how you boil the eggs. That's it. Nothing else. You can get very good bass from a ported enclosure if you don't get carried away with the Q factor and with proper tuning. As a rule, we all set low tuning, but you need a driver that can do all that, yeah. That's when we're talking about a three-way system. Sealed enclosure. Well, let me tell you, a long time ago, I spent quite a while researching acoustic enclosures. The goal was to see which one could reproduce a kick drum perfectly. That is, you record the kick drum with a microphone, and then you record the speaker the same way. Exactly the same, yes, with a microphone. That's how it is. As you might have guessed, we had only one winner. This is an open baffle design, yes, which is why bass reflex designs are used. He got a complete copy, yes, that is with all the harmonics, with the full impulse response. You could basically get a copy without any problems, right? Next, a large closed box and a low-tuned bass reflex design also weren't much different, right? But the small closed box did whatever it wanted. That is, there was no attack as it should have been, right? But the harmonics, my dear friends,
Very beautiful.
Very beautiful. So this clear bass of yours, when you pay attention to it for a long time, you'll notice that it's actually a bit uniform, right? That's exactly what emphasizing the harmonics is. In a large box, this is less pronounced. It sounds more interesting, but in a small closed box, there's no question about it, right? That's it.
Well, a nice bass in a closed box.
Yes, its benefit is it doesn't mess with the phase, right? And the distortion rises like crazy, obviously. And another advantage is that it still shows a small bump in the impedance curve, but the amplifier only benefits from that, right? Well, so those are the advantages, right? But when you treat the bass reflex the same way, right? Meaning you don't use it as an amplifier, but as a tool that relieves compression in the speakers, right? Then you also have, if you also put some thought into the room and match the second impedance with the room's problems, you can get such speed from the bass reflex that there will be no point in using a sealed box, right? That's it. So that's my opinion, which is based on many years of working on this issue. And as for what he also asked, whether it's possible to use a sealed box, yes, it is possible. A sealed box is no problem. There you go. If the room is small and boosts the low end, yes, you can close the port, right? It works in this same enclosure volume too, right? If you want it for movies, you can also make a smaller box for movies. So, in this box, we have the absorbers laid out as needed. Basically, you can arrange them however you want, however you like. That's it.
Why not?
Why not?
Guys, if you have any questions, please ask them in the comments. And if you are in Latvia, in the description of the video, there is a link to our address. You can come to us, listen, test, even with your own amplifier, ask all your questions, and see all the charts. Right there on the spot, you can measure exactly how it sounds here, a meter forward, a meter back. This was Arkady Zenin from Premium Hi-Fi and Roland from Reflector Audio, the lead engineer of the company whose mission is to make the sound at home and in the studio the same as musicians hear it. That's all. And may the force of the sound that's right for you be with you. Come visit us. Roland, thank you for the interesting stories and answers to the questions.
Wishing everyone happiness.